Energy released by an earthquake is released in the form of something called seismic waves. There are two types of seismic waves. There are P waves, which stands for primary. These are compressional waves. They squeeze and they stretch as they move in one direction. P waves can travel through solids or liquids. The second type is what's called an S wave, or a secondary wave. This is a longitudinal wave that moves up and down as it progresses in one direction. Now, S waves cannot travel through liquids. They can only travel through solids. However, S waves usually lead to more damage during an earthquake because of their up and down motion. There is a third type of wave. It is called a surface wave. There's a few types of those like Rayleigh or love waves, and essentially that's what P and S waves become when they reach the surface. They can move in very interesting ways. We are able to record seismic waves by using a seismograph, and that seismograph produces a printout called a seismogram, and there's a variety of information that we can get from that seismogram. All we need to know is when the arrival of the first P wave is and the arrival of the first S wave. And then you can see there is this interval, this time between those two arrivals. And that tells us essentially the distance to that earthquake epicenter. And so we are able to locate it. The other piece of information that can be gotten from a seismogram is the magnitude of the earthquake. We measure the height of the highest S wave, and that tells us the magnitude of that particular earthquake. Valuable information gleaned from the seismograph and the seismogram to learn more about particular earthquakes. Now, seismic waves, their arrival time tells us how far away it is. And if we know that distance from, say, 3 locations, then essentially that distance from each location tells us it must be somewhere on a circle that distance away. And if we find 2 of them, then we know it is located either here or here. And then if we find 3 seismographs, then we can triangulate the location of that earthquake epicenter. It comes from these seismograph readings. What you can see is each one has different P and S wave intervals. So arrival time of P wave, arrival time of S wave, arrival time of P wave, arrival time of S wave. These are all different measurements. These times here are all different, telling us that each one is a further distance away, and that allows us to triangulate the location of that earthquake epicenter. The last thing that they are used for is we're actually able to determine the interior of the Earth based on seismic waves. How the P and the S waves travel through the interior of the Earth or don't travel through tells us what the different layers are like. P waves and S waves are bent and reflected and blocked, and that lets us know the different properties of the interior layers of the Earth. For example, the layer that we are on is the crust. If you think of the Earth as a peach, this would be the skin of the peach. Then beneath that is the mantle. Again, thinking of the peach, this would be the juicy part that you eat. It makes up the majority of the planet, and it has some very weird properties. It has some properties like a solid, some properties like a liquid. Think of it as a putty or something like that. It moves, and it moves very slowly. And then we have 2 cores. We have the outer core and the inner core. The outer core is liquid iron, and the inner core is solid iron. Again, we've never drilled into the interior of the Earth very far, mostly into the crust, but we know all of this because of using seismic waves to tell us what the interior of the Earth is like based on their rate of travel and their speed of travel and what they're able to travel through and what they are able to not make it through.